Definite integral 8, Riemann sum to integral. The limit n goes to infinity, summation I goes from 1 to n, root of n squared minus I squared over n squared represents an integral, integral a to b, f of x dx. What is the integral? Recall the Riemann sum formula. Limit n goes to infinity, I goes from 1 to n, f of xi, delta x, that's the integral a to b, f of x dx. This is a right-hand Riemann sum where delta x with equal partitions, that's equal to b minus a all over n. What we're given is limit n goes to infinity, I goes from 1 to n, root of n squared minus I squared all over n squared. So let's do some algebra first to put this into a different form such that we have a delta x of the form 1 over n somewhere inside the summation. So I'm going to divide by n squared here, divide by n squared, and divide by n, because root of n squared is equal to n is positive. So dividing by n squared inside a radical is equivalent to dividing by n outside a radical. If we simplify this, we get limit n goes to infinity, I goes from 1 to n, root of 1 minus I over n all squared all over n. This is equal to limit n goes to infinity, I goes from 1 to n, root of 1 minus I over n squared times 1 over n. This is delta x. So xi is equal to I over n, and x1, plugging I equals 1 here, you get 1 over n, x2 is 2 over n, x3 is 3 over n, xi is I over n, and xn is n over n, which is equal to 1. So xn is equal to 1, that's equal to b. So a is 0, b is 1, and to find a, all we have to do is take the limit as n goes to infinity of x1, 1 over n. And as n goes to infinity, this limit approaches 0. That's why a is equal to 0. So what we have is a is equal to 0, b is equal to 1. We have f of xi is equal to root of 1 minus xi squared. That means that the function f of x is equal to root of 1 minus x squared. We also have delta x is equal to b minus a over n. That's 1 minus 0 over n. So what we have done is we've transformed the Riemann sum, limit n goes to infinity, I goes from 1 to n, root of n squared minus I squared all over n squared, into a definite integral from 0 to 1, root of 1 minus x squared dx. It turns out that we can compute the above integral since y equals root of 1 minus x squared is the top half of a semicircle of radius 1 with center 0, 0. So let's show that. Y is equal to root of 1 minus x squared. Let's square both sides. We get y squared is equal to root of 1 minus x squared all squared. That gives us 1 minus x squared. Bring the x squared, bring the minus x squared to the other side. We get x squared plus y squared is equal to 1, which is a circle of radius 1 with center at the origin. If we were to plot this, this is the upper half of a circle. So this is y equals root of 1 minus x squared. And we're integrating from 0 to 1, so the shaded area is the value of the integral from 0 to 1, root of 1 minus x squared dx, which is pi times radius squared. The radius is 1. 1 squared times divide by 4 is pi over 4. This is the area, the shaded area, which represents this definite integral. All right, thank you.